Okay. Morning, everybody. Should we start? Yeah. All right. So last time you saw that by using a transformation, I reduced a nonlinear equation into a linear separable equation, right? So now there's another equation which is called the isobaric equation. And let me write down the equation. So this you have to actually so when we talked about y over x form, so there you could see that the degree has to be the same. So let's say if there is some x square y over here, there has to be some x cube over here. And you can immediately see that this is not the case here, right? So in such a case, you want to do something so that you reduce the system again to this kind of a form. But for that, we used to use some weight method, and the recipe is that x and dx are given the weight 1 and y and dy are given the weight m. Okay? And you will have to use y is equal to v x raised to power m, and what we need to find out is what m is for a particular differential equation. Okay? So now let's try and use this method. So if I use weight 1 for x and dx, then what will x squared dx give me? 2 plus 1, right? Because 1 x dx, the 1 plus 1 is 3. Y dx would be, y is m. M plus 1, good. And what about this one? All right. So when you write down an equation and you put it equal to 0, then in order to make sense, everything has to be of the same order, right? Otherwise, apples can't be placed next to oranges. So what is the obvious choice for m now? For this equation to be consistent? 2. Yeah. So in this case, I will have y is equal to vx squared. So now just take the differential. You will have x squared dv by dx plus 2xv. Write this equation and tell me what you get. Go ahead. So I don't want to do everything on the board for you, so because mathematics means you have to do certain things by yourself, right? देखिए अब, can you reduce it into an equation which is tractable now, which you can solve through the already known methods? How many of you have encountered this differential equation? Well, not the ComSat ones. आप तो वैसे ही फ्लोरिडा स्टेट यूनिवर्सिटी में स्पेशल मामलात हैं. Pardon me?
Why is it called the isobaric?
Isobaric because you give weights, right? So it has nothing to do with the physics isobaric. It's just an equation that. The simplest way to do it, of course, is that you write down x square minus y is equal to dx is equal to minus x dy. You write dy by dx is equal to minus x square minus y over x, and then you plug things in so that you get the answer.
M minus 1.
Sorry?
M minus 1.
Minus 1. Everything has to be 3. 3 होना चाहिए ना, on the same footing. m अगर 1 हो गया तो फिर तो -1 हो गया तो फिर तो 0, 0 and 3 तो क्यों जी? I mean, just to see that you get some form where it is easily integrable. That is the whole idea, right? Okay, so that is what it is. So if you look at the 14th chapter of Riley and Hobson, you will find more examples, and on the net you can find many examples. But the basic idea over here is that you have to give weights, because this is not in a form where you can apply y is equal, because for that you need to have f as y over x form. But over here you can do that by this weight method, and that is why this isobaric differential equation. Same weights, right? Same power you have to have. So, pardon me? आ गया ना आपके पास इंटीग्रेटिंग फैक्टर के फॉर्म में, मतलब ये वो कहना चाह रही हैं कि आपके पास कोई इक्वेशन dy by dx प्लस p of x y is equal to f of x की फॉर्म में आ गया. e raised to power integral px dx आप करें, multiply throughout, you will be able to write down in terms of an exact differential, integrate and get the answer. आपके पास सेपरेबल फॉर्म में आई है. ये तो बिल्कुल आपके, हाँ तो अगर ये बताओ क्या है तो ये आप अपना चेक करो. उनके पास आया 1 प्लस एक्स डी एक्स और क्या है
1 plus v dx
v
dx plus x dv.
x dv. So that is okay. So this is now in separable form. 1 plus v dx is equal to minus x dv. You will have dv over 1 plus v is equal to minus dx over x. Everything is in the form of log, and the matter is. हाँ ठीक, okay, good. So this is the idea. ये सब थोड़ा सा अलजेब्रा का प्रॉब्लम है, आप लोग अपने नोट्स आपस में कंपेयर कर सकते हैं, राइट? अहमद साहब कुछ समझ आई? हाँ बस दैट्स ओके, बट you understand the basic concept that each term should carry the same weight, and that is how you determine the unknown m, because this is the thing that you need to put in here to reduce your equation. So everywhere you have to have this kind of, and then some equations can be quite tricky also. Okay. So this is one of those equations where you apply a method which is generally not applied, but it works very well, and it's of the same form, y is equal to vx, except that you have a power over here, and that is why Riley and Hobson puts it just after y is equal to vx. All right. जी जी
Sir, we normally assume the solution, but it also makes sense somehow. For example, if we choose the exponential function to be our solution, then the power comes into the constant, right?
So this
So
is something that which is not very obvious. Yeah, I totally agree with
yes.
you.
So how
But the
can
only
we
thing that you
think?
need to know is that what you want to do, and basically it's the same idea that you want to make. So I told you this, that let's say you have this. So the idea is that these degrees should be the same. So your whole idea, when you recognize something which is not of the same degree, you try and make them of the same degree so that you can apply that method. But for that, you have to say that now I have to do something, and that something is to give weight. And by giving that weight, you actually end up doing the same thing that you do it with y is equal to vx, except that now you have to, these equations are of not the same degree, and you have to make them of the same degree. That is the idea. So yeah, in that sense, this is not in a proper format. This is something that you have to appreciate by inspecting the equation, differential equation. Very true. So these are all substitution methods. And now I will tell you something. Okay, so there is another equation, dy by dx. So if you have everything is in the numerator, then it becomes very easy. This is not in terms of a fraction p over q form. So if you have this, so then the whole thing is that you just need to assume that this is, and once you take the derivative and substitute, you will get your answer. Okay. For instance, he has given an example here, so let me try and write. So this is very simple now. Again, you see, you must understand that the problem stems from the fact that you have something written in the form that you can't write it in terms of a separable equation. And now you have to devise some way to solve this. Okay? So therefore you just write v is equal to x plus y plus 1, and then you will have dv over dx is equal to 1 plus dy over dx. You make this substitution, dy over dx is equal to dv over dx minus 1. Now substitute and tell me what you get. So this is dv over dx minus 1 is equal to v squared, dv over 1 plus v squared is equal to dx, and the matter is resolved. So everywhere you eventually reduce your system into, a set of equations which you can easily integrate. That is the whole idea of method of substitution. But you should also see that these are all nonlinear equations. So these substitutions reduce your nonlinear equations into linear equations. That is the thing which is most astounding here, that these transformations are very, very non-trivial, that reduce a very complex system into a very simple system. Okay? And of course, mathematicians had to work these transformations out. Again, I told you that they'll look at the equations, try and find ways to solve them, and they come up with immense ease. The problem becomes trickier when you have the same thing but in a different form, and that form is ax plus by plus c over dx plus ey plus f. Now there is no way that you choose a single v, because something is written in terms of a fraction and those two fractions are different. Okay? So in this case, what you say is that my x is equal to x plus h and my small y is equal to capital Y plus k. Okay? The beautiful thing is that when you take the derivative, the small x will give you capital X, the small y will give you capital Y. Okay? So this will become all right. And what about this? All right. And now if you write this down, you will have now tell me what is the impediment in my, and can you see certain parts which you have already seen and where you can immediately come up with a solution? जी मैडम, क्या ख्याल है? अगर मैं एक लम्हे के लिए इनको सुलेमानी टोपी पहना दूं, so this thing is great. I just need to put capital Y is equal to V capital X and the problem is resolved. But this is the impediment in my way. And you have these two unknowns over here as well. Okay? So in order to have a completely determined system, what do you need when you have two unknowns? Two equations, right? You need to have two equations. So there you go, the obvious choice. AH plus BK plus C is equal to 0. DH plus EK plus F is equal to. All right. Once you do that, everything is known except the H and K's. So this is a completely determined system. You will find H and K. You will plug in there and you have this equation. So you will apply Y is equal to V of X. You will solve it. Go back to from V to again. You see when you write it down like this. So you will eventually, when you get your answer, you will plug this back. But the situation is still not done because this was in small y and small x. So then you will have to eventually make this y plus k and x is equal to, sorry, small x is equal to capital X plus h. So capital X would be x minus k and your small y is equal to h है, अच्छा ठीक है h है तो h कर लें जी कोई, nothing sacrosanct about that, but the way I define ought to be like this, and this capital Y would be y minus k. So let's try and do an example so that you grasp the idea. अहमद ये सब कुछ किताबों में दिया हुआ, आपने शेयर कर ली इनके साथ किताबें? हाँ अच्छा बस ठीक है, फिर ठीक है. पिक्चर्स आप ऐसे बनाया करें, अच्छी बात है. नो प्रॉब्लम. All right, so let's write down a problem. So dy by dx is equal to 2x minus 5y plus 3 and 2x plus 4y minus 6. So now you have to make this x plus h, y plus k, plug it in there and write down two equations and tell me what are the values of h and k. So that will give you some confidence in your ability to solve it. I will just kickstart it so this will become d capital Y over dx, and you will have 2 capital X minus 5 capital Y. I will have 2 capital X plus 4 capital Y, and then I will have 2H minus 5K plus 3, and I will have 2H plus 4K minus 6, and I need to put these two equal to 0. Go ahead and tell me what H and K are.
K is equal to minus 3 is equal
आप देख रहे हैं, इसको सेपरेट कर लेंगे इसमें से, तो माइनस 5K माइनस 4K इज माइनस 9K, 3 plus 6 is 9, उधर गया तो माइनस 9, तो K क्या आ गया 1. Plug it in here. 2H minus 5 plus 3 is minus 2 is equal to 2H is equal to, ठीक है, Agreed? अब आपके पास and now what is the equation that you need to solve? dy by dx is equal to 2x minus 5y over 2x plus 4y, which is in the form y over x, same degree. अब आप इसको जब सॉल्व कर लेंगे तो कोई आपके पास आंसर v इज इक्वल टू समथिंग आएगा, उसमें आप y जो है वो आपके पास कैपिटल y इज इक्वल टू दिस है, तो v जो है वो y ओवर x आ जाएगा, और ये y जो है इसकी जगह आप y माइनस 1 लिख देंगे और इस x की जगह x माइनस 1 लिख देंगे, और जहाँ जहाँ यहाँ भी आपके पास जो भी चीज़ होगी, क्योंकि कैपिटल x और कैपिटल y में होगी ना, तो वो भी आप चेंज कर देंगे. सो दिस इज द होल आइडिया. क्वेश्चंस प्लीज आस्क. So now you have learned that even if you have something in terms of fraction which are very intractable, and we know we cannot reduce them into separable form by using the substitution method, and by forcing the condition so that you get the h's and k's so that the constants are put equal to 0, you can reduce this thing into a well-known form, solve it, replug the values, and everything will be done and dealt with. ठीक है? No questions?
Sir, this seems very forced to me because you make.
Yes,
the
we are
transform-
forcing it. You're right.
Sir,
If we don't
make-
force it, then we can never solve it, and that is the whole idea of doing this, so that we can find the h's and k's for which this equation can be solved.
So you make a transformation and then put constant equals to 0. So
Yep.
why can't we just remove 3 and minus 6, and that would be a same equation?
But how can you do that? I mean, if I say 3 equals to 0 and 6 equals to 0, does it make any mathematical sense?
Sir, why we are putting these constant
Because
equals
this
to
I
0?
can do.
Why, sir?
This is perfectly legitimate to say that these two equations, these two terms are put equal to 0 because they can be equal to 0 for a certain choice of h and k. But over here, if you say just get rid of it and put it equal to 0, you can't do that.
सर हमने इसमें इस तरह ट्रांसफॉर्मेशन किया कि काउंटर सर मैं अगर इसको थोड़ा एक्सप्लेन करूँ तो फिर आप इसको ठीक करेंगे।
जी, जी।
हमने इस तरह ट्रांसफॉर्म किया इसको, मतलब ये डिफरेंशियल इक्वेशन को इस तरह डिफॉर्म किया, मतलब कि इसमें काउंटर टर्म ऐड किया ताकि ये 3 और -6 ये ख़त्म हो जाए और हमारे पास वो सेपरेबल फॉर्म।
जी, of course. The whole idea is to get rid of the constants. But you know, you have to pay a price for that as well. That if once you do that, then you have to solve these two equations as well. But of course, what was at the back of our minds the moment we saw this, immediately, so you see, this is the logic. This is a means to an end. What is the end? To get this thing which I can solve. And the means to that end would be this substitution, and then forcing the condition that in order to make it, you know, tractable, you have to put these two equal to 0. Main idea wahi hai, okay, I can immediately identify that I need to get rid of this. Yeah. So in this case, the more you learn and the more forms you know, you immediately, your mind is working in that direction, how to get rid of certain things to reduce it into a form which you can handle very easily, or which you have learned to handle, right? When you do the transforms and you reduce the differential equation into an algebraic equation, why do you do that? Because algebraic equations are way more, they are way more easier to handle because you have done that many times before. तो अगर आप d2y over dx square plus dy by dx plus y is equal to 0 किसी को दें और x square plus x plus 1 is equal to 0 दें, तो वो immediately वो कहेगा ये quadratic equation है, quadratic formula लगाओ और हो जाए. तो ये that is, it's just that it's the physics में, in mathematics, in physics, you have equations which come about looking at the system, and then you have, I mean, the basic thing is there is this dependent variable and there is this independent variable. I need to solve this. So this is a simple equation, but you can have many equations, and you will have many unknowns. So the whole idea of everything over here is to reduce the number of unknowns. You can use a constraint, you can use a constant of motion, you can use all the existing knowledge so that, or some symmetry, so that you can make the problem easier to handle, right?
And sir, because it seems that we are making a perturbation.
No perturbation. Which perturbation are we trying to make here? This is not a perturbation at all. This is just a substitution.
So will we lose some solution? Will we lose some solution?
Over here?
Yes.
Well, look at this equation. So, well, it depends eventually what you get, and from that solution, is it something? पहली बात तो ये कि वो, when you say कि losing a solution, so there are certain solutions that you can, by investigating, identify. Over here, you can't identify all the solutions that are. Can you come up with anything? No. It depends also, you see, in which particular form. So keep this question with you, and we are going to now look at some equations, and that will give you a general idea of how to get an equation where you have a proper solution and how do you get the singular solution, and I will classify it properly. Yeah. ये मोहसिन साहब ने आपको नहीं करवाए थे उसमें, हाँ नहीं करवाया होगा, ये भी नहीं करवाया था, लेकिन अब जो हम करने लगे हैं वो तो आपने प्रॉबली मुझे नहीं, आई डोंट नो कि आपने किया या नहीं, बट इट विल गिव यू. सो दिस इज very nice clean mathematics, you see, but you should realize that just by adding a harmless 3 and a harmless -6 can make your life very, very difficult. Okay? तो ये एंटिसिपेशन नहीं कर सकते आप, आपको ख्याल में आपने कांस्टेंट ऐड कर दिया, बट बेसिकली यू हैव चेंज द स्ट्रक्चर एंड नाउ यू हैव टू कम अप विद सम स्मार्ट सॉल्यूशन टू सॉल्व द प्रॉब्लम. ओके, so let's try and now solve a problem which is quite well known and in physical problems. So let's start with the Bernoulli's differential equation. All these problems come under the major heading substitution method, yeah? Solving by substitution. All right. So this is the form of Bernoulli's equation. So let me write down Bernoulli's All right. So, Ahmed, I'm going to ask you first. If you look at this equation, without looking at the book, can you make any comment about what the value of n should be to make it a nonlinear equation? Because you see, here you have, yeah, this is a nonlinear first order differential equation. Well, partly true. Do you agree? If it is less, it can't be nonlinear. What if n is half? But there is a consensus that it could be anything, but so this it cannot be. आप मुझे बताएंगे क्यों नहीं हो सकता n is equal to 1? क्या क्या मत आ जाएगी अगर if n becomes 1? Will heavens fall? Pardon me? Why? Just tell me, if n is equal to 1 here, how would I classify this equation then? Linear equation, yeah. So for the nonlinearity, this will never be the case. Okay? Answer should be precise. All right. And again, by using a substitution method, you can solve it. And the substitution in this particular case is that this is the substitution. All right. What will this substitution do? Any educated guess? Without solving it, any guess? Now that you have done quite a few problems, what is your anticipation? I would say if I have to answer, I'll choose two educated guesses, but can you come up with those two educated guesses? Two educated guesses, not one. Yeah, good. It has to linearize it, otherwise we don't know how to solve it. And what else? Yeah, so either it can become a linear equation or it can become a separable equation. Yeah, so these are the two forms that it can reduce the whole thing into. So the best thing is to look at a problem and solve it. So let me write down the problem. dy by dx plus y over x is equal to 2x cube y4. बताइए मैडम n क्या है यहाँ पे 4. Okay, so 1 minus 4, v is equal to y minus 3. So now what I need to do, just take the differential and see what happens to this equation. Go ahead, do it. That would also give me an idea, that you can get to somewhere. This is the whole idea. If I do everything for you and you don't do anything, then I think that is not the idea.
Watching sports.
Yeah, watching sports, yeah. The dribble that you can see of Ronaldo or Messi. But if you go to the ground, then you will be all at sea. Oh, how does he do that? Now I realize how difficult it is to, dodge a person with my dribbling. So Hasan sir, while they are doing it, I have an idea, you may or may not agree, but I think that, through hard work and by doing something over and over again, some kind of intelligence can be acquired. But when it comes to genius, then that is something that I don't say you can achieve through hard work.
But you have to have the capacity to work.
Work harder, yeah. So without hard work, you will never get to anywhere actually. That's what I think, because in all these matters, unless you sit down, try and work out things, develop an idea.
The best example probably is Galva, who was only
Yeah,
very young when he invented this theory of groups and normalized it.
yeah. But Vesa was telling us that Riemann, came up with Riemannian geometry at the age of 21. This Euclid was also a childhood prodigy, So, that is something, they are in a different plane, yeah. So, nature doesn't believe in equality. So, when I think equality has to be defined in a certain manner. Professor, this could be a topic of discussion sometime. Can genius be acquired? Do we need to have a certain, environment?
Right now we are seeing what is happening in China.
Yeah.
How come they are getting now 2 field medals this year they got, and they are leaders now in Western music also. So
Yeah. True.
I remind you these days all broadcast live.
Yeah. हो गया? Very good. तो जब हो गया तो आपके पास what did you get? Eventually, did you get a linear equation or did you get a separable equation? Linear equation. Okay, good. So you know how to solve it. You can use the integrating factor and solve it. Okay. So once more in the substitution method, you learn the power of a transformation, a substitution, which reduces a nonlinear problem into a linear problem. Just like in PDEs, you always try and reduce your PDE into an ODE and then solve it. Okay? So over here also, so even if you are dealing with nonlinear ODEs or PDEs, you will have to reduce it into a form which you know how to solve. Up, please.
सर फंडामेंटली सोल्यूशन सब्स्टिट्यूशन करने में और सोल्यूशन गेस करने में क्या फ़र्क होता है? मतलब कि हम यहाँ पे भी टेक्निकली एक तरह से गेस नहीं कर रहे कि सोल्यूशन जो है वो इस फॉर्म की होगी.
So my answer that it is a hit and trial. It's not that you came up with something straight away. So you try and come up with something that fits the bill, and by hit and trial you end up with this. But then you see, when you are dealing with lots of this stuff, then you also develop an intuitive feel that what works in a particular case, it reminds you of the previous cases that you dealt with. So these are the things that people, spend in their entire lives doing. Okay? So for instance, my friend Mohsen, he was doing his PhD with another friend. So they were trying to find out certain transformations that reduce the existing equations into some tractable form. So sometimes, it takes them months, and sometimes they don't succeed at all. So it's a non-trivial problem. But now you do straight away. It was not that simple when somebody saw it for the first time and tried to solve it. I don't know, it took Bernoulli how many years to solve this problem, but of course, it's not that he came up with this on the very first day that he looked at this problem. Okay. All right. Now we can talk about. So I think I can talk about another equation now and the rest later, because I will talk about the higher degree equations later. So let me talk about another equation, okay, which we call Riccati equation. All right. And so generally when you write the differential equation like this, and in this particular case, what you have is P of x plus Q of x plus, I think, y, yeah, definitely y. I think that's true, yeah. It can go on and on, but then it won't be a Riccati problem. For Riccati, it should stop here. So you can see that you can get a Bernoulli from here as well. Okay? If I just put this equal to 0, so you will get the same Bernoulli, right? So this is the method that I'm going to tell you works only when you have nonlinearity, power 2, yeah. y has power 2, maximum power 2. Okay. So you can't solve this problem. It is impossible to solve this problem unless you know at least one solution to this problem by inspection. Okay? And then you can come up with some transformation which can make it tractable. So you have to assume that you know one solution, otherwise you can't do it. So let me write down a problem and then we will see what we can do. So let's say dy over dx is equal to 2 minus y plus y square. I guess this is the problem, right? No, minus 2 minus y plus y square. All right. So now by inspection, can you tell me one solution to this problem? Y is equal to 2 seems to be. Any other? Y is equal to minus 1 is another problem solution. But let's say there is one solution that I know, okay? And let's say it is 2. So my substitution will be z is equal to 1 over y minus 2. Okay? Try and do it now. You will have to write everything down now in terms of a new variable z. And you have to solve that equation and you have to tell me what does this transformation do to this differential equation and then plug it back to find out the solution. Go ahead.
Because don't P and Q have to be functions of x, as it says here?
No, I mean, they can be. That is not a condition. But as long as they are of this form and we can identify one solution, we can solve it. That's a very good question because these are constants over here, coefficients. But in principle, you can have something which is a function of x. Easiest thing would be you write y is minus 2 is equal to 1 over z. Your dy by dx will be minus 1 over z squared dx. You plug it in here and you try and find out the solution, and instead of y you will write what? 2 plus 1 over z. So basically what you will have over here is square. dz over dx
equals to minus 3z
okay, so you can write plus 3z
plus 1
is equal to
equals to minus 1.
yeah कैसी इक्वेशन है ये इक्वेशन को क्या कहेंगे? Linear equation. So linear equation के लिए you know that you will just have to use this. So your integrating factor will be 3x, and you multiply, you will write it in terms of an exact differential, and eventually when you get an answer in z, you will plug 1 over y minus 2 and you will find the solution. Questions? Please ask. I've told you the limitation of Riccati equation, but when you will solve nonlinear PDEs, in many cases you try and reduce into Riccati form also. So Riccati form is Riccati's differential equation, which is the first order nonlinear equation, is a very important differential equation. It has connection with many nonlinear differential equations. So again, these kind of standard forms that you try and reduce your, let's say, a nonlinear PDE into, because you know it has a solution. So the more you know, the more you try and reduce your interactable equations into these particular forms that you know about. That is the whole idea. जी. Sorry? Of course, R of x तो उसके बगैर तो ये non-linear equation ही नहीं बनती ना. Yeah, so you are right. R of x can never be 0. True. Otherwise, it's a linear equation. Yeah. So what she is trying to tell you is that when you look at an equation, you can also talk about the limiting cases. When it becomes Bernoulli, when it becomes a linear equation and all of that. So just like we said in the case of Bernoulli's equation that for n equals to 1, it becomes a linear problem. So n cannot be 1 to be termed as a Bernoulli's equation. Okay? All right, so now we will go and talk about the higher degree equations. I think this is something that probably most of you have not encountered, and it would be. ये कितने लोगों ने concepts वाले छोड़ दें, बाकी you guys have seen these equations? Good. किसने पढ़ाई है? मोहसिन ने रिकार्टी करवाई थी. ये सेट के अच्छा वो उसने हाई डिग्रीज नहीं करवाई, फिर हाई डिग्री नहीं करवाई होगी. बनूली भी नहीं करवाई. बनूली तो अगर आप ये कर लेते हैं तो खैर वो ऑफ कोर्स द ट्रांसफॉर्मेशन इज नॉट द सेम. So we had very few lectures to cover a lot of stuff, so over here as well. So the thing is that, but I just wanted to do this in full glory so that you can see the linear and non-linear, at least first order ODEs in their full glory. I have tried to cover most of the stuff that is given in the graduate and undergrad texts. Okay, so now we go on to deal with a different beast. Higher degree differential equations. And of course, I must say that here that it is we are talking about the first order. That is very important because dy over dx whole square is not as d2y over dx whole square. All right. So first things first. So we started at 9:45. So 11:15, so I still have half an hour. I think that should be more than enough. Okay. What is P? Because we are going to deal with the higher degree equations, so we are going to define our P is this. Okay? This is how we define P. So when I say solvable for P, it means this is my equation. And if I can write my equation in this form, which is this, so if I have some higher degree equation and I can factorize that equation like this, then I can say that I can solve it for P, okay? But let me first write down something. So let me write down the equation. So, and then I'll also write it down without P so that you can immediately understand what is the advantage of. So this is the equation. So if I use the P notation, then the ease that I get for myself is very obvious, that I just don't have to deal with this thing again and again, and I can write this as so this is P squared, P and a constant, okay? So you can solve it for P if you can write it in such a form that it can be factorized. Okay, so the guy says that this can be written like this. So let me write it down and I'll give you 5 minutes, else I'll tell you, but so this is what it is. X plus 1p minus y x squared plus 1p minus 2xy is equal to 0. This is how it can be factorized into. So I give you 5 minutes to convince yourself that this factorization is correct. So if you're reading a book and he says this is the equation, this is the factorization, then you have to do it yourself to convince yourself that this is correct. You can do that, but once you do that, then it will also tell you that what are the algebraic tricks he has employed. So it requires a bit of rearranging of certain things, writing certain things in certain forms. Should I leave it as a homework? Yeah.
Sir, I don't think it's always factorized.
So equation solvable for P assumes that you are given an equation which can be factorized. If it cannot be factorized, then we can't talk about anything. So it has to be, so we are not saying that any higher degree equation written in any form can be solved using this method. No. As long as I am given an equation, a higher degree equation, and I can factorize it, then I can solve it.
I thought maybe we could write it in terms of like complex numbers, complex solutions.
This is all in real plane, my dear, this course. No complex variables whatsoever.
Euler's formula used to we can write it in terms of sin and cos.
Real variables हैं. Solution तो और चीज़ है ना. ये पहले भी बात हुई थी उस दिन, in the presence of प्रवेश साहब भी बात हुई थी. I don't know whether internet works here or not, but let's say I can have an equation, some d omega over d2 omega over dz squared plus something into something is equal to something, and it has to be nonlinear also, where this omega is complex. Okay? So that is a different thing altogether. Over here, you have y and x. They are real numbers. You are talking about the real plane. You are not talking about. Equation can be written as, I mean, I told you that a simple harmonic oscillator, it gives you oscillatory functions which are nothing but exponential iota theta, right? So, but that doesn't mean it's a complex equation. It's a differential equation with a complex solution. And these are two very different things altogether, right? Over here you have to take care of many other things, like Cauchy-Riemann's equations and other things, but G.
सर जैसे हमारे पास रियल डिफरेंशियल इक्वेशन है ना, उसको सॉल्यूशन कॉम्प्लेक्स हमारे पास आ सकता है, जैसे कि ऑसिलेटरी की आपने एग्जांपल दिया, तो क्या ऐसा भी हो सकता है कि हमारे पास कॉम्प्लेक्स डिफरेंशियल इक्वेशन है, उसका सॉल्यूशन रियल आए? क्या कभी मतलब ऐसी
रियल से
कोई
क्या मुराद है आपने?
मतलब उसका सॉल्यूशन ई रेज़ टू पावर आयोटा थीटा की फॉर्म में ना एक्सप्रेस किया जा सकता हो, कॉम्प्लेक्स डिफरेंशियल इक्वेशन हो कोई ऐसी, क्या अभी तक कोई ऐसी आपने सॉल्व की है जिसका सॉल्यूशन
I have not solved any complex differential equation till
तो
now.
मतलब
You
ये
know,
चीज़
I would
possible
love to
है?
learn it. So maybe Hassan Saab, I'll learn from him. But anyway, let's come back to something with the. Okay, so tell me. Anybody try to. Okay, if you run into any problem, we can do it. No problem, but this is how I get the factorization. So, of course, two things are being multiplied and they are giving me 0, so it means I will either have x plus 1 p minus y is equal to 0 or x square plus 1 p minus 2xy is equal to 0. Okay? So let's try and deal with this one first. So I will have x plus 1 dy by dx is equal to y, and I will have dy over y is equal to dx over x plus 1, and it's a matter of 1 minute to say that this is y is equal to c x plus 1, right? Have a look here. X square plus 1 dy by dx is equal to 2xy, dy over y is equal to 2x over x square plus 1 dx, and this can be written as log of x square plus 1. So I can write this as y is equal to c x square plus. Okay. So how many solutions do I get now? I will get y minus cx plus 1, y minus c x square plus 1 is equal to 0, and this is solved. Okay. This is what we call equation solvable for p. This is a higher degree differential equation, and if you can factorize this equation, then you can come up with a solution. Please ask. Yeah.
C root x square plus 1.
C root? Root means what?
2x है ना, तो मैं बोला कॉन्टिटी नहीं हो.
सही है ना? जी.
सर हम किस फॉर्म में लिखते हैं? आई थॉट वी राइट इट लाइक y is equal to इस तरह ना, पहली जो सॉल्यूशन थी उसके टाइम्स ए कांस्टेंट प्लस दूसरी सॉल्यूशन टाइम्स कांस्टेंट, मुझे जनरली लिखते हैं जनरल.
हाँ, but you have two equations which are multiplied together, so you have got.
I'm asking कि इस तरह लिखते हैं या उस
Yeah,
तरह लिखते हैं?
this is how you write. These are the two solutions. Because these are two differential equations multiplied together. This is not one equation, right? Okay, now let's try and do another one. Chaliye, let's try and do this one. So the differential equation that you are given is the following: 6y square p square plus 3xp minus y is equal to 0. अब आपको कैसे पता चलेगा कि सॉल्वेबल फॉर x है, सॉल्वेबल फॉर y है, सॉल्वेबल फॉर p है? That by looking at this equation. So if you see only x appears once, okay? So I can write this as all right, and then I can write this as good. So now everything is written in terms of y and p, and x is isolated. So solvable for x. But the rest of the terms have been taken on the other side. Now you need to p अगर मैंने बनाना हो तो how can I make it p? If I differentiate it with respect to y, so what would I get? Dx over? And what is dx over dy? 1 over p. So you will have 1 over p is equal to 1 over 3p minus y over 3p squared dp over dy minus 4yp minus 2y squared dp over dy. Right? अब अगेन जरा इसको try and write it terms of some factor. मैं लिख देता हूँ वो फैक्टर ताकि आपके पास आंसर हो. इसको आप देख रहे हैं dp over dy है, and you just factorize it, and this is what you get. ठीक है. अगर आप इसको सॉल्व करें, let's try and solve it. So you will have dp over p is equal to minus 2 dy over y, and of course I can write this as p is equal to cy squared. What is your name? Ibrahim, can you work it out, and can you tell me how we can write this as cy squared? Can you see it the way I can see? -2 जो ऊपर जाएगा वो y squared हो जाएगा and you will have p is equal to cy squared. What about this one? What is this equation now? Basically, do you know how to solve it? No, it cannot be solved. If you take it there, divide it by this, there will be some under root. Yeah. This sort of an equation where you do not have an integration constant is called the singular solution. So this is the solution that you have, this part, and this is the singular solution. जी जी हमने कर तो लिया एक, बट ये भी एक solution है, ये भी एक solution है. This is a singular solution, this is a normal general solution because it can be written in terms of an integration constant c. So the normal proper solution is the one that you can write with an integration constant, and the one that you cannot write is called the singular solution. So that is, in these higher degree equations, that is the way that you can identify amongst the solutions which one is the singular and which one is the normal solution. By looking at the equation.
सर मैं ये कह रही हूँ कि कोई तो मेथड होगा ना इसको सॉल्व करने का. हम कैसे ये कह सकते हैं सिर्फ देखते हुए कि इसको किसी तरीके से भी सॉल्व नहीं किया जा सकता और ये सिंगुलर सॉल्यूशन है.
This is an equation which cannot be written in this form and properly, it's not in the integrable form straight away. The others are. So the one which can be solved using the separable equation method or the linear equation, generally they are all separable equation methods, so they will always come up with a constant c.
सर तो इससे पहले जितने हमने मेथड्स पढ़े हैं उनमें भी तो नॉन लीनियर इक्वेशंस होती थी, लेकिन हम उसको रिड्यूस कर लेते थे लीनियर में और फिर सेपरेबल में सारी
Yeah, so
चीजें.
this is higher degree. Now you, for the first time, you are dealing with a higher degree differential equation, and when you come up with these kind of equations, then every time you factorize, you will have two parts. In some cases, you will have both with a constant c and they are proper solutions. In most of the cases, you can identify just by looking. So I'm going to do another thing.
सर
but
इट मींस के इससे पहले जो हमने नॉन लीनियर की थी वो इन टर्म्स ऑफ वेरिएबल डिपेंडेंट वेरिएबल y थी, लेकिन अभी हमारे पास
But
क्योंकि
degree one.
डिग्री, हाँ अब डिग्री क्योंकि
yeah,
ग्रेटर
yeah.
है
So
तो
that's why I'm saying higher degree equations may you will. So when you, that's what I'm saying. You incrementally increase the complexity in the differential equations and you come up with new results.
ओके.
And you can identify certain things which you cannot identify in the other cases. Right?
ओके सर.
Over there, if you remember, you wrote something down in terms of a constant, but or the general solution. But from the general solution, you couldn't get one of the solutions that you could see
यस,
just by inspecting the equation. And you said
दैट इज अ सिंगुलर
that
सॉल्यूशन.
is the definition of a singular solution in that case, where you had degree 1. Now you have a higher degree equation, and now in order to identify, you use this way. Ji.
ओके सर.
That's for the singular cube, can't we just solve it as well? So it's singular solution.
करें आप इसको सॉल्व करें. ये पी स्क्वायर है ना, देखें ये आपके पास डी वाई बाई डी एक्स का स्क्वायर है. ये
सर हम
अब जो भी चीज आपके पास आएगी ना, यहाँ पे देखें आपके पास जो भी चीज आएगी ना, वो एक प्रॉपर फर्स्ट डिग्री डिफरेंशियल इक्वेशन की फॉर्म में आएगी. एनी हायर डिग्री वुड बी क्लासिफाइड एज अ सिंगुलर सॉल्यूशन. अभी हम एक मैं आपको लेट मी, ये बार बार देखने से भी फेमिलियरिटी जो है ना वो breeds understanding also. Let me just do it for y and let's see what happens then. I won't spend much time but just write and tell you what we get. So over here, this is the equation, xp square plus 2xp minus y is equal to 0. As you can see, y is the only one here. So I can do y is equal to xp square plus 2xp. When you plug this solution in the original differential equation, that solution would be called the singular solution. And when you will put this solution in that equation, that will be the regular solution. So just for the sake of completeness here, I will write them down. Y cube is equal to 3cx plus 6c squared is what you get when you substitute this differential equation into the original differential equation. And when you put this differential equation in the original equation, you get 8y cube plus 3x squared is equal to 0. So now you can clearly see that this is the solution, normal solution, and this is the singular solution, because the singular solution will always be without c. There will be no c over there. Okay, and that's the best way of identifying something. But anyway, going back again here.
Sir, मुझे एक confusion है. Sir,
एक minute, just let me do this and then we will talk about all the confusions together. So once you do this, you will have this thing. P plus 1 and P plus 2x dy by dx is equal to 0. Okay, yeah, P plus 1, P plus 2x dp by dx. Yeah. All right. So if you solve this, you can immediately see that you will have something with a constant. And if you plug this in this original equation, you will get x plus y is equal to 0. And in the other case, you will have y minus c whole square is equal to 4cx. So again, this is a singular solution and this is the normal solution. Now ask your question, please.
सर सिंगुलर सोल्यूशन की डेफिनेशन मैं ये समझती थी कि अब इक्वेशन को सॉल्व करते हो इनफाइनाइट नंबर ऑफ सोल्यूशन आ सकते हैं, लेकिन फिर भी एक सोल्यूशन होगा जैसे y इक्वल्स टू 0.
इन्फिनिट नंबर ऑफ सॉल्यूशंस तो आप जो आपने ये वाली एग्जांपल की थी, और यहाँ पे आपने जब सॉल्यूशन लिखा था, if my memory serves me right, it was of this form. So no matter which value of c you take, although y is equal to minus 2 satisfies this differential equation, you can never obtain y is equal to minus 2 from any choice of c here. And that is, so that doesn't mean that there are infinite number of solutions here. No matter which value of c of you consider, you will never get y is equal to minus 2. It doesn't mean infinite solutions exist. It means
सर सेट ऑफ इन्फिनिट नंबर ऑफ सॉल्यूशंस तो एग्जिस्ट करता है क्योंकि आप c की कोई भी वैल्यू चूज कर सकते हो.
जी
लेकिन फिर भी y इक्वल्स टू -2 आप नहीं ले सकते जो कि सिंगुलर सॉल्यूशन बनेगा, ऐसे ही है ना?
But you define, again, I again repeat the definition. A singular solution in this case is defined as a solution which cannot be obtained from a general solution.
Yes.
Because in principle, a general solution is one from which all the solutions can be obtained.
Yes, sir.
At least in the linear theory.
Yes, sir.
And I told you the problem here is again this power 2. This is a nonlinear equation, and now it behaves in a way which is very, very different, drastically different from the linear behavior.
तो हम इक्वेशन सॉल्व करके सिंगुलर सॉल्यूशन नहीं निकाल सकते.
Solve करके तो निकालते हैं, because you have solved it you have plugged it and you have found the singular solution.
Sir, इसी
But
चीज़ में-
again, you see, you have to differentiate between the different cases. This is first degree, first order differential equation. This is a higher degree, first order, higher degree differential equation. So identifying things would be very different in the cases because solving methods become very different. And you are dealing with now the powers of the derivatives. So that is why the classification, how it is done, becomes different.
सर फिर general definition क्या होगी singular solution की?
There is that is the whole idea. So अभी मैं वो कह रहा हूँ ना, partial differential equation, infinite singularities हैं. Can I spell all of them out? The answer is no. But in general, they can exist in that system, right?
सर इसको
इसके
हम
हम करो.
सर इसको हम इस तरह सोच सकते हैं कि एक डिफरेंशियल इक्वेशन है, उसको हमने सेपरेट किया, मतलब फैक्टराइज किया. एक पार्ट में डिफरेंशियल आ गया जिसकी वजह से कांस्टेंट ऑफ इंटीग्रेशन आ सकती है, और दूसरे जो है वो अलजेब्रिक बन गया.
Absolutely. That is the whole idea, that one that you get in algebraic form will eventually give you, yeah, so
सिंगुलर सोल्यूशन अलजेब्रिक जो
well, over here you see like this. Again, you see algebraic form ये भी है.
यस सर.
So I told you, anything that you identify as a separable part, that is going to give you a constant of integration, and once you plug this solution back in your equation, you will get something which involves C, because the solution here gives you C. But over here when you plug it in, there is no C. Because well, you're right, it's in algebraic form.
सर उसका सोल्यूशन CY² इक्वल्स टू 1/P नहीं होगा?
Sorry?
CY² इक्वल्स टू 1/P.
Log of P.
माइनस है ना, तो पावर्स और रेसिप्रोकल ही रहेंगी.
हाँ, तो ये I mean ये इसको PY² is equal to C. Yeah. Okay. Thank you. Yeah. Perfect.
सर
जी.
आप ज़रा थोड़ा फिर से समझा सकते हैं कि इक्वेशन सॉल्वेबल फॉर वाई पी और एक्स में क्या फ़र्क था?
यही फ़र्क है कि over here x and p appear twice, y appears once. In x appears once, y and p they appear twice. ठीक है? And now the last let me just get done with it and then you can ask here. अच्छा, okay. Okay, go ahead. हाँ.
सर p+1 को इक्वल्स टू 0 अगर हम करेंगे तो हम dy by dx इक्वल्स टू -1 लिख सकते हैं. y इक्वल्स टू -x प्लस c क्यों नहीं लिख रहे?
आपका p जो है ना, ये इक्वेशन उस फॉर्म में लिखी हुई है. सो आई पुट p is equal to -1 and you see p is equal to -1 will give me x प्लस माइनस, ये यहाँ पे -1 है ना, हाँ, तो -2x minus y is equal to 0. So minus x minus y is equal to 0 and x plus y is equal to 0.
सर इसको हम दूसरी तरह क्यों नहीं कर रहे? इंटीग्रेटिंग फैक्टर की टर्म्स में क्यों नहीं सॉल्व कर ले?
Because I am solving in terms of p and these are the solutions.
सर लेकिन आपने तो लिखा था
ये
equation solvable
already
for P.
in terms of p मिला हुआ है. I am doing something in p and this is already telling me that p square is equal to -1/6y. So I will just plug it in and solve it. इसका मकसद यहाँ पे ये नहीं है कि you try and integrate it.
सर तो
Because this is higher degree. So you just plug it in and see what you get here because it's already in there. दूसरे cases में you have to solve it because dy by dx, y you have to put as something. X you have to put as something. But once you get something like this, so I can just plug it p in terms of that variable.
सर तो क्या हम ये कह सकते हैं कि ये सिंगुलर सॉल्यूशन इन टर्म्स ऑफ p है, इन टर्म्स ऑफ y नहीं है? क्योंकि अगर हम इसको y की उसमें
Equation ही
देखें
p में है. ये हायर डिग्री है.
तो
अगेन
सर p को हमने डिफाइन
आप
तो
लोग जो
किया
है
ना
ना,
in terms-
यू गाइज बिकॉज यू आर नॉट राइटिंग इट इन टर्म्स, आपको नोमेनक्लेचर के साथ प्रॉब्लम हो रहा है. ये इक्वेशन ये है. So when I know what dy by dx is straightforwardly, then I don't have to integrate it. because it's already known. So I just plug it in. Solution is not the problem here. You just need to factorize, and whenever you factorize, there is one thing that you can straight away put, the other you have to solve to get something. That is in the form of a first order differential equation, separable equation. The other is, as he rightly pointed out, is an algebraic expression. Okay. So let's see the.
Waqas, I think we are over time.
Just 1 minute overtime. I'll just take 1 minute. Just want to finish this topic here today. This is the Clairaut's equation. This will end our discussion on the nonlinear ODEs. The equation is okay. So you take dy by dx and you will have okay. So this is P, this is P, PP gets cancelled out, and you will have x plus df over dp, dp over dx is equal to 0. Okay? अब dp over dx क्या है? dp over dx का क्या मतलब है? d2y over, so d2y over dx square is equal is c1x plus c2, and this is the singular solution. So you see, Nishad, this is where probably you are most comfortable with, because now everything is in terms of P, so you don't think that you can just integrate it. The problem is the moment you see something in terms of x and y, you say, let's divide it into y and x and do it. So in this particular case, if you take dy by dx, so P will be equal to C1. So once you see this equation, the solution would be C1x plus f of C1. This is your solution. And the singular solution would be df over dp plus x is equal to 0. So that completes all that I have to say about the first order linear and nonlinear ODEs, and this is higher degree. This is, so things can be more complicated, but of course they are beyond the scope of this particular course. So now we can stop and you can ask questions.